Okay, today we're starting on chapter 10, where we talk about graphing square root functions. We're going to start by defining radical functions. A radical function is where the independent variable occurs inside the radical. So as you can see here, f of x is equal to the square root of x. Okay, so here's what this graph looks like. F of x is equal to radical x. You can see here that the graph starts at the point 0, 0, and it goes to the point 1, 1, because the square root of 1 is 1. We also see that at the point where x equals 4, the square root of 4 is positive 2. You'll notice that negative square roots are not included as they are imaginary numbers like we talked about, so they don't show up on the graph. So you'd notice that if we did graph the square root of negative numbers, it would turn out looking like a sideways parabola with this line here reflected over the x-axis. But doing the vertical line test, if we draw a vertical line through a function and it hits 2 points, it's no longer a function. So that's why we only include positive square roots. If we continue going, we can also see that the square root of 16 is 4, and so on and so forth. Let's talk about some transformations. So you'll want to note down that when we're doing transformations of radical functions, it's important to always apply translations inside the radical first, before all other transformations inside or outside the radical. The translations outside the radical happen last. So let's start by doing horizontal translations. So here's my next function, the blue. So the blue is going to show translations. If I put inside the radical a negative number, like this, we see that the graph moves to the right. So technically the notation for this transformation is f of x minus h. So because the transformation horizontally is always minus, when we say x minus positive 2, the graph moves to the right because the number being subtracted is positive. Well, let's say that we take the same function and instead of subtracting positive 2, we subtract negative 2. Now we see that the graph has moved 2 units to the left. Okay, so x minus 2 means it's moved twice to the right, while x minus negative 2 means x has moved twice to the left. Let's talk about vertical translations. Vertical translations happen outside the radical, and they work just like the transformations for parabolas. If we say radical x plus 3, then the graph moves up 3, and in the same way, if we say radical x minus 3, the graph moves down by 3. The third type of transformations is reflections. These are a little bit trickier. So basically we're saying whether or not the graph flips over the x or the y-axis. The transformation over the y-axis goes as follows. F of x equals the square root of negative x. You can see that the graph then flips over the y-axis and goes this way. So think opposites. If x is being affected by the negative sign, then it flips over the y-axis. So the notation for this is technically f of negative x, because the negative is only affecting whatever x's are inside of this function, so this is a reflection over the y-axis. A reflection over the x-axis is when the negative goes outside of the graph, like this. Now you see the negative is affecting all of f of x. So if f of x is originally this, then we take that graph and we plug it in, and then we apply the negative sign to the entirety of radical x, and we see that now the graph reflects over the x-axis here. So when the f of x is all affected by the negative, or you could say the negative's on the outside, then it reflects over the x-axis. Let's talk about horizontal stretch or shrink. Here's our original parent function. When we talk about stretch or shrink, the number is going to go inside the radical, so f of a times x. What that looks like is if I put the number, or a, some number, inside of the graph. So here is an example of horizontal shrink. Horizontal shrink is when the number is greater than 1. So we can see that it's getting shrunken, it's being squished up, as if you're taking two hands on the outside and kind of squishing them together. If it's a horizontal stretch, that means the graph is going to get longer and longer horizontally, and that's when x is a fraction, or x is between 0 and 1, like this. So now the green graph, you can see, is getting flatter and flatter. It's being stretched horizontally. So here we see 1/5, or basically the larger the number on the bottom gets, the more stretched horizontally it gets. All vertical stretches or shrinks occur on the outside of the radical. So what that means is you take all of f of x, or this entire section here, and you multiply it by some number. that means the number is going to go on the outside. Let's start off with vertical stretch. A vertical stretch means the number is on the outside of the radical, and it's also greater than 1. So you can see here, as I increase the number, it gets stretched vertically more and more and more. So vertical shrink will be the opposite. A vertical shrink will happen when the number is on the outside of the radical and it's a fraction. So here you can see it's getting shrunken vertically, meaning it's getting shorter and shorter and shorter. The more I increase the number on the bottom of the fraction, the more shrunken vertically it gets. Here, if we were to really zoom in here, we could see exactly how shrunken it is. So if we go back to our parent function, let's talk about identifying different kinds of transformations. So let's say that we're given the graph g of x is equal to negative radical 3x, and you're told to identify the transformations happening to it. We know that we have to apply transformations inside the radical first. So we're going to start off inside here, and we're going to say this number is inside the radical, which means that it has to be horizontal stretch or shrink. Because that number is greater than 1, it's a horizontal shrink by a factor of 3. Okay, so we're done identifying the transformations inside the radical, so we can move outside now. And we see that the negative sign is outside of the radical, which means that it's affecting all of the graph, meaning it's technically affecting all of g of x. If it's affecting g of x, that means it's a reflection over the x-axis, as you can see here. It's being reflected over the x-axis, and it's being shrunk by a factor of 3 horizontally. Here's another example. I have g of x is equal to 1/4 radical x plus 3. Starting inside of the radical, I can see that I have plus 3, which means that it's technically the same thing as saying minus negative 3, meaning that it's been moved to the left 3 times. So it's being moved left 3. We also see that it's being affected by a number on the outside of the radical, meaning that it's a vertical stretch or shrink. Because that number is between 0 and 1, we see that's a vertical shrink by a factor of 4. I'm going to attach here a little chart for you to copy down in your notes, and hopefully that helps you with your homework. I also suggest that you play around in Desmos to kind of get a feel for this on your own as well.